right, hello. Chapter 2. Two variables now. Chapter 1 was one variable. Chapter 2 is two variables. Two variable categorical data. So during this video, you're going to learn how to construct and interpret two-way tables. Most of the time, you're going to learn what a conditional distribution is. You're going to learn what a marginal distribution is, and then you're going to learn how to construct and interpret stacked or segmented bar charts. So, two-way table. A two-way table is exactly what it sounds like. Basically, you have two variables, and you set up one so that it varies by row, and then your other variable varies by column. So, for example, if you have young adults by gender and chance of getting rich. So you have a individual, you're surveyed males and females, and instead of just asking everybody what they thought about their probability of getting rich was, you also separated it by males and females and kept track of that data. So you have male and female on the top, separating it as columns, and then by rows you have the how many said that they thought that they were going to get rich and their probability. So you see you have almost no chance, some chance, 50-50 chance, a good chance, and then almost certainly getting rich. And then of course you have the totals on the side and on the bottom. On the side you have the totals for each row, and of course on the bottom you have the totals for each column. And then in the bottom right hand corner you see how many people in total were surveyed. So in this case 4,826 people. What a stacked bar chart does, or what a segmented bar chart does, it takes the cumulative information for one variable and stacks it together into a single bar that represents 100% of that data from that variable. So for example, instead of just graphing all of the men and their probabilities for getting rich, you take each of those values, find the percentage of those men who answered one or another, and then you stack it up so that the bar reaches 100%. So at the bottom you see the percentage of men who said they have almost no chance. The green area represents the percent of men who said they have some chance. The yellow area represents the percent of men who said they had a 50-50 chance. The red area here represents the percent of the men who thought they had a good chance. And then the purple area on the top represents the percent of the men who thought that it was almost certain that they would get rich. A conditional distribution is basically the distribution that you use to make a stacked bar chart. It looks at just one of the variables. Well, it takes one of the variables, and instead of looking at both, for example, both the male and the female, it just looks at the male side and then separates it into the percentages. So you have here the conditional distribution for the men, and then on the right you have the conditional distribution for the females, so males and females. And then what you can do is you can compare the conditional distributions using these segmented bar charts, and from those you can come up with a conclusion. Now, the conclusion that we're going to come to isn't going to be anything that's set in stone. What we're going to do is we're going to determine whether or not there is a possible association. If there is an association between two variables, it means that the category of one of the variables has an effect on the outcome of the other variable. So for example, if there was an association between your gender and the probability of you getting rich, then that would suggest that your gender has an effect on your probability of getting rich. Now, what do you do to determine that? Well, if it made a difference what gender you were, then that would suggest that perhaps the distribution for males would look different than the distribution for females and vice versa. So if you have these segmented bar charts, all you have to do is look and see if there is a difference. Because if there's no difference between being a male and being a female, as far as your probability of getting rich goes, then the conditional distributions should look the same, because if there's no difference, then it wouldn't matter. So all you have to do is look at the segmented bar charts, and if they don't line up perfectly, then what you do is you say, we may have an association between the two variables. You can't say for certain whether or not there is an association yet. We'll learn how to do that later on in the year, like almost at the very end of the school year. But you can say, if there's not, or you can say that there may be. So if these lined up perfectly, then we could say, okay, yes, there is no difference in the male and female conditional distribution. Therefore, it doesn't matter whether you're male or female, your probabilities of getting rich would be the same. However, since we're looking here, there is a difference, small yet noticeable difference between the two distributions. We can't say that there's no difference. Therefore, the opposite of there is no difference is there might be a difference. So we would look at this distribution and we would come to the conclusion that there may be an association between gender and your chance of being wealthy by age 30, specifically, according to this. And that, in a nutshell, is the bulk of two categorical variable analysis, right? One last thing to look at is a marginal distribution. A marginal distribution of one of the categorical variables in a two-way table basically counts the distribution of values in that variable among all the individuals in that table. And a lot of times it's better to describe it as a percent. The way you do it is use the data in the table to calculate the marginal distribution in percents and the rows and the columns, and you make a graph. Now, what that is translated is essentially you're making a distribution of the totals of one of the variables with respect to another. So a marginal distribution for the chance of getting rich would basically be where we look at the totals over here on the right-hand side, find the percentage of those, and then make a bar chart out of that. It sounds like it's an oversimplification, but that's because it is. It's basically, if we don't want to look at it compared males versus females, if we only want to look at, okay, well, what about everybody total? Well, we essentially ignore one of those variables and just look at the rows. And that is a marginal distribution. Hope this was helpful.